Imagine a world hidden beneath the waves, a vast, dark, mysterious realm, teeming with secrets and possibilities. This is a place where sunlight barely reaches, and silence reigns supreme. For centuries, the ocean's depths have been a frontier of both wonder and danger, a place where only the bravest dare to venture. For decades, the U.S. Navy's submarines have been the silent guardians of this world, moving unseen and unheard. These vessels glide through the deep, protecting our nation's interests and gathering intelligence, all while remaining invisible to those above. But the ocean is getting more crowded and dangerous. Commercial shipping, fishing fleets, and rival navies now crisscross the seas, making stealth and security more challenging than ever before. To stay ahead, the Navy has launched a quiet revolution. This transformation is reshaping not just how the Navy fights, but how it thinks, plans, and adapts to a rapidly changing world. This isn't about bigger ships or louder cannons. The days of brute force are giving way to a new era of precision and adaptability. It's about intelligence, speed, and innovation. Robot submarines, super-smart computers, and factories that can print metal parts on demand. The Navy is embracing cutting-edge technology, from artificial intelligence to advanced robotics, to outpace any threat. This leap is changing everything we know about sea power. The very definition of naval dominance is being rewritten as new tools and tactics emerge. The Navy's goal? A hybrid force, human sailors working side by side with intelligent machines. This partnership will unlock new levels of efficiency, safety, and capability. Together, they'll form a network that's faster, smarter, and more resilient. Information will flow instantly, connecting ships, submarines, and command centers across the globe. This new fleet can see farther, react quicker, and protect global interests with fewer lives at risk. The stakes are high, as the world's oceans become more contested and unpredictable. In the cold waters off Norway, a submarine crew achieved the impossible, launching and recovering a robotic vehicle from a torpedo tube while deployed. This breakthrough opens up new possibilities for underwater missions. Back in the US, engineers use lasers and metal powders to repair parts in days, not months. This rapid innovation keeps ships and submarines mission-ready, no matter where they are. In secure data centers, AI algorithms identify threats faster than any human. Cybersecurity and digital warfare are now as critical as torpedoes and missiles. Each advancement is a piece of a much larger puzzle. The Navy is building a future where every innovation fits together, creating a force that's greater than the sum of its parts. The Navy's innovations will ripple across the world, shaping our economy, safety, and international relationships. Allies and rivals alike are watching closely, knowing that whoever leads at sea shapes the future on land. Understanding this revolution is key to understanding the future. The choices made today will echo for generations, influencing everything from global trade to national security. The silent service is becoming even quieter, but its impact is greater than ever. Beneath the surface, a new kind of power is rising, one that values brains as much as brawn. This is how the U.S. Navy is preparing for tomorrow, today. The next era of sea power has already begun, and its story is just starting to unfold. For decades, the U.S. Navy's dominance beneath the waves was considered untouchable. American submarines prowled the oceans with near impunity, and the Navy's technological edge kept adversaries at bay. But as the years passed, other nations invested heavily in their own submarine fleets and cutting-edge sensors. Suddenly, the vast ocean began to feel much smaller, and the Navy's advantage was no longer guaranteed. Simply building more of the same submarines, using the same old strategies wouldn't be enough to stay ahead. The world was changing, and so were the threats. The Navy realized it needed a fundamental shift, one that would embrace emerging technologies and rewrite the rules of undersea warfare entirely. The answer wasn't to put more sailors in harm's way, but to let machines take on the dull, dirty, and dangerous jobs. Unmanned systems could go where humans couldn't, and do what humans shouldn't. Enter unmanned underwater vehicles, UUVs, paired with artificial intelligence to process the overwhelming flood of new data, making sense of the chaos beneath the surface. This transformation began with a new mindset: fail fast, learn fast. The Navy encouraged rapid experimentation, knowing that quick failures would lead to faster breakthroughs. Borrowed from Silicon Valley, This approach let the Navy test, adapt, and refine ideas at a pace never seen before in military circles, forging partnerships with the tech industry to accelerate progress. Special units like UUVGRU-1 and the Underwater Confidence Course became living laboratories for innovation, where new tactics and technologies could be tested in real-world conditions. Here, engineers and sailors work side by side, pushing technology to its limits and building a force ready to adapt and overcome in a new era of undersea competition, one where agility and innovation are the keys to victory. At the heart of the Navy's undersea revolution is the Unmanned Undersea Vehicle, or UUV, advanced robotic submarines that come in a wide variety of shapes, sizes, and capabilities. These innovative machines are transforming how the Navy operates beneath the waves, offering new possibilities for exploration, defense, and strategic advantage. Some UUVs are compact enough for a single sailor to launch by hand from a dock, while others are designed to be loaded and deployed from a submarine's torpedo tube, seamlessly integrating with existing naval platforms. Unlike remote-controlled toys, these sophisticated vehicles are fully autonomous, able to navigate the ocean's depths and carry out complex missions independently, without direct human control. Today, every U.S. submarine can deploy these robotic partners, dramatically extending their operational reach and allowing them to monitor vast areas of the ocean far beyond the limits of their own hulls. A submarine commander can now send a UUV to map the ocean floor in detail, search for hidden mines, or scout out safe passages through dangerous waters, tasks that once put sailors at risk. After completing its mission, the UUV can be recovered, serviced, and prepared for its next assignment, making these vehicles a reusable and reliable asset for the fleet. Cutting-edge UUVs like the Razorback and Rat Trap Ivor 4 deliver real-time intelligence, advanced mine detection, and surveillance capabilities, dramatically increasing both the safety of Navy personnel and the freedom with which they can operate in contested waters. Even commercially available remotely operated vehicles, or ROVs, are now used to inspect submarine hulls, replacing the need for divers to perform these hazardous tasks and reducing the risk to human life. The Navy's vision is clear: underwater robots that can inspect, clean, and maintain submarines, freeing up skilled sailors for more critical and demanding missions, and ushering in a new era of undersea operations. Integrating advanced robots wasn't easy. The USS Delaware, a Virginia-class attack submarine, was chosen to test the Yellow Moray system, launching and recovering a large UUV through a torpedo tube at sea. Early attempts failed: a lost UUV, a damaged docking sonar, and a mission scrubbed. But instead of giving up, the Navy embraced its new culture. Failure is a step toward success. Engineers and sailors analyzed what went wrong, repaired the vehicle, and improved procedures. In May 2025, the Delaware crew finally succeeded, launching and recovering the UUV multiple times in Norway's challenging waters. This historic first proved a deployed submarine could use a sophisticated UUV as a reusable tool, a true force multiplier in the undersea domain. Underwater robots collect staggering amounts of data, far more than humans can process in time. Enter artificial intelligence and machine learning, the brains of the operation. AI analyzes acoustic data, instantly picking out enemy signatures from ocean noise. Through the AUKUS partnership, the US, UK, and Australia developed a shared AI algorithm, outperforming any single nation system. AI also streamlines life aboard on the USS Pasadena, a generative AI prototype/paperwork, freeing sailors for critical tasks. With over 1,700 UUV sorties worth of data uploaded to secure cloud systems, the Navy's AI learns fast. During a NATO exercise, UUV data was sent via satellite for real-time analysis, showing a future where commanders get instant, clear pictures of the battlefield. Submarines are complex machines, and when a part breaks, traditional repairs can take months. Advanced manufacturing, especially 3D printing, lets the Navy produce replacement parts on demand, right where they're needed. On the USS New Mexico, over 35 different 3D printed parts are in use, proving the technology's readiness. Cold spray repairs, which rebuild damaged metal without heat, have saved months of dry dock time for subs like the USS Rickover and USS Virginia. These innovations make the fleet more agile and self-sufficient, reducing dependence on long supply chains. The result: a stronger, more resilient submarine force, ready for action when needed most. In most organizations, failure is feared, but in the Navy's submarine force, fail fast, learn fast is a guiding principle. Setbacks aren't disasters. They're data points that make the final system stronger. At underwater confidence courses, over 1,700 UUV missions have intentionally pushed systems to their limits. Every lost robot or failed sensor is a lesson, accelerating progress. Vice Admiral Robert Gauscher champions this culture, insisting that delivering new capabilities quickly, even if imperfect, is better than waiting for perfection. This willingness to learn from failure keeps the Navy agile and ensures it's always preparing for the next challenge, not the last. The Navy's transformation is about more than hardware, it's a culture of relentless improvement. Vice Admiral Gauscher sees the Delaware's journey from failure to success as proof of a winning mindset: adapt, innovate, overcome. Apex predators survive by being the smartest and most adaptable. By embracing AI, robotics, and rapid innovation, the Navy ensures its submarines remain the deep's undisputed hunters. But technology alone isn't enough. Skilled sailors and smart command structures are essential. UUVGRU-1 is training a new generation of sailors, comfortable with both subs and autonomous vehicles. Rear Admiral Todd Evans emphasizes, in future conflicts, the side that makes better decisions faster will win. The Navy's goal is a seamless team of humans and machines dominating the decision cycle. The Navy's revolution beneath the waves impacts us all. Oceans are the highways of global trade. Over 90% of commerce travels by sea. A smarter, stealthier fleet keeps these lanes open and deters aggression, ensuring economic stability. Navy innovations will spill into civilian life. Better robotics for exploration, advanced manufacturing for industry, and AI breakthroughs for medicine and logistics. International partnerships like AUKUS strengthen alliances and uphold a rules-based order. Ultimately, this is about preparing for an uncertain future. By embracing innovation and empowering people to work with intelligent machines, the Navy builds a more resilient force, one that promises a safer, more secure tomorrow for everyone.